Hello friends, welcome back to my YouTube channel MS Maths. In this video, we are going to discuss about the PY question of GATE ECE branch, Engineering Mathematics, and particularly in this video, we'll discuss ordinary differential equations PYQ. So basically, to understand the concept of ordinary differential equation, you can visit my one short video on my YouTube channel MS Maths. Here I will discuss 20 plus years PSL question with these short tricks. So first let me start the topic. Yes, we will have first question. It is basically related to second order ordinary differential equation. We have differential equation of the form of y t square y double dash minus 2t y plus 2y is equals to 0. Okay, whenever you will have this kind of differential equation in which the independent variable is multiplied with the derivative term, then it is nothing but t square d square and t of d. Now you are just going to replace this with m and m minus 1. Okay, and this will be the only m. So the auxiliary equation for this will be m minus 1 minus of 2 will be there, and it will be m, and plus 2 is equals to 0. Now what is this? This is m square minus m minus 2m plus 2 is equals to 0. Then this will be m square minus 3m plus 2 is equals to 0. Now the root of this is basically m minus 2 and m minus 1 is the factor. Then m is equals to 2 and 1 are the root for this like auxiliary equation, basically auxiliary quadratic equation. Now the important thing is that here like you are basically going to like replacing this with, so basically it is the thing that you are replacing your independent variable with e to the power of z to convert this differential equation to a constant coefficient differential equation. It means, so the solution for the second order differential equation is y, and it will be the complementary function and particular integral, but it is a homogeneous. It means my right hand side is equals to 0, or sorry, yeah, right hand side is equals to 0. It means the complementary function be the only solution for this differential equation, not the particular solution. So the complementary function will be in the form of z. It means I will replace my z with the original t variable, original independent variable after that. Okay, now it is what y of c is nothing but, if it is a real and distinct root, then it is c1 e to the power of 2z plus c2 e to the power of z. It is in the form of z, not in the form of t. Just remember this thing. Now you are going to replace this, then it will be y of c is equals to c1 e to the power, or it will be, yeah, it will be log of t will be there, and plus c2 e to the power log of t will be there. And of course it will be c1, it will be t square, and it will be c2t. Now you have two boundary conditions are there. One is y dash of 0 is equals to 1. Okay, what is the y dash here? Y dash is nothing but 2c1 of t. Okay, and plus c2. Now if I will put t is equals to 0, then I will get 1. So 1, so yeah, like y dash is equals to 1, then it will be 2 c1 and 0 plus c2. Now the value of c2 is nothing but 1. Again I have another condition, that is basically y dash 1 is equals to minus 1, and it means I will put 1 here in this case. So I will get minus of 1 is equals to 2 c1 1 plus c2, and I can find from here my c2 is nothing but minus of 1. Okay, now c1 adds, so yeah, not c2, c1 is 1. So I will have the solution, that is basically the complementary function for this particular differential equation, and that is basically the c1 is 1, so it is 2 of t. Yes, it is no, sorry, it is a t square. It is t square and minus of t. Now it is saying that the maximum value of this differential equation. How can we find the maximum value? If we will have if we have this kind of solution, this is my y t square minus of t, then if I will differentiate this, then it will be dy by dt is equals to 2t minus of 1. Now how can I find the differential equation? First I will find the critical point. I will just put dy by dt is equals to 0, then it is 2t minus 1 is equals to 0, then t is equals to 1 by 2 is the critical point. Okay, if it is a critical point, then is it a like maximum or not? I will just like this, I will find d2y by dt square, and of course it will be 1 second. It will be, I think my c1 is 1. then just let me check it. If it is a minus of 1, then minus 1 is equals to 2, then it will be plus, this will be, yes, C1, and it will be plus 1, then it will be minus of 2 by 2. Yes, C1 is my minus 1. Yes. Okay, now like I have this one. If I will differentiate this, then I will differentiate again this, I will get 2. Now, is it like a maximum point or not? How can we say that? Because it is nothing, it is not like this. If it is C2, my C2 is 1. C2 is 1 and C1 is minus 1. So it is minus 1 and it is plus 1. Minus 1 plus 1. Yeah, it is minus 1 and plus 1. Then it will be 1 by 2, of course. Okay, yeah, it will be minus of 2. If it is a minus of 2, it means it is negative. Negative means that it is giving the maximum. Now, what is the maximum value for this? Then this critical point will be put in this solution, and that is basically minus 1 by 2 whole square plus 1 by 2, and that is minus 1 by 4. Okay, plus 1 by 2, and that is nothing but 1 by 4. So 0.25 will be the correct answer for this question. Okay, next question. Yeah, next we'll have a question. In this case, they are asking about the general form of the complementary function of differential equation. So in the case of second order differential equation, first of all, you should know about that what is the kind of general form of the differential equation. So if we have second order differential equation, then the solution of differential equation is complementary function plus particular integral. Okay, so the general form of complementary function of a differential equation given in that case, it is like this. So it is y of t is equals to a t plus b e to the power of minus of t, where a and b are real constant determined by the initial condition and the corresponding differential equation. So it is saying that for what equation this is the complementary function. So just like think over it. If you have this kind of differential equation, it means it is a repeated kind of root. Whenever we will have a repeated root, then we'll just write like this: c1 plus c2 t e to the power of alpha and t, where alpha is the repeated root. So what is the repeated root here? It is minus of 2. So this one is the root. So if it is a root, then like go with the reverse process. What we are going to do? We are going to do basically the auxiliary equation. So what is the auxiliary? What is the root of the auxiliary equation? Is minus 2. It means it is nothing but it is basically like plus of 2 whole square. It means it is nothing but from here my m is equals to minus 2 will be there. Okay, yes, so like m plus 2 and 2 roots will be there. So this is the differential equation. If I will open it, then I will get m square plus 4m plus 4 is equals to 0. If I will replace my m with the derivative portion, it means it is the d of 2 plus 4d plus 4, and it will be if I will multiply with y is equals to 0, then what is this? This is nothing but d 2y by dx square plus 4 dy by dx plus 4y is equals to 0. If it is not 0, then it will be function of 3. So the first option is the correct option for this case. Next one. Next question is related to the position of a particle y of t is described by the differential equation. This is the differential equation. It is again a second order differential equation, and in this it is saying that the initial condition is given here and the position accurate up to 2 decimal places at particle t is equals to pi. Okay, so we have a differential equation like this: y double dash plus y plus 5 by 4 y is equals to 0, and the auxiliary differential equation is m square plus m plus 5 by 4 is equals to 0. If we are going to find the root for this differential equation, then we can use the discriminant method, that is minus of b plus minus b square minus 4ac upon 2a. Okay, this will be the root. So like m, so my m is nothing but minus 1 plus minus 1 minus 4, and that is basically 5 by 4 divided by 2. We will have m is equals to minus 1 plus minus, this will get cancelled, and it will be minus of 4 upon 2, then it will be minus 1 plus minus 2 iota divided by 2. Okay, then it will be minus 1 by 2 plus minus iota Now, if we will have this kind of solution, alpha e to the like alpha plus iota beta, then it will be e to the power of alpha. Okay, e to the power of alpha t plus, multiply c1 cos of beta x plus c2 sine of beta of t. Now this will be my y, so here it is e to the power minus 1 by 2. Okay, e to the power minus 1 by 2 t, and it will be c of cos of t plus beta sine. This will be c2 sine of t. Now if you will put y0 is equals to 1 and y of 0 is equals to, or y dash of 0 is equals to 0, then you will get, and after that you will get c1 and c2, and after that you will get t is equals to pi, and that will be minus 0.23. Okay, so this will be the solution for this. Okay, next we'll have a question. A curve passes through the point x is equals to this one. This the basically curve passes through the point, and in this case we have differential equation. We'll have to find the solution of differential equation. How can we find the solution? It is basically, differential equation is dy by dx is equals to x square plus y square upon 2y plus y by x. Then we can't separate this basically, so we can just write it as dy is equals to x square plus y square upon 2y, and it will be y by x and dx. Now what we can do here, from here, if we take it as like this, dy is equals to, this will be the x square plus y square and plus 2 of y square, then it will be it is basically 2y of x, taking the LCM dx. If I will take 2y here, then it will be 2y dy is equals to x square plus y square. Okay, of course the x will be here, then I can just simply write it as 2 of y square upon x dx. Now I'm like, somehow I'm going to just separate it using this. We can use here u is equals to, we can use u is equals to y square here. So what will happen in this case, that du is equals to 2 of y dy by dy by dx is here. Okay, now in this case this will be du upon dx will be there. So we can just write it as nothing but du is equals to 2y dy. Then we can replace over here, this is du, and it will be x square plus u square plus what is 2y square, it will be 2 of not u square, it will be 2 of u here only, and upon x and d of x. Okay, now we can write here, it is du over dx is equals to x square plus we can just add it, or we can write it as u. Okay, then it will be, if we will take u common, then this will be 1 plus 1 upon x here. Now what can I do here, that is du by dx minus of 1 plus 1 upon x, u is equals to x square. Now it is what, the linear differential equation. Now what can I do here, I can find the integrating factor. So the integrating factor, okay, yeah, it is 2, not 1, it is 2. So the integrating factor is basically, this is my p, so it will be e to the power of minus integration of 1 plus 2 upon x dx. So it will be e to the power of minus of x. Okay, it will be e to the power of minus of x minus 2 log of x, then it will be e to the power minus x, e to the power of minus 2 log of x. We can just separate it, and it is e to the power of minus x, and it is nothing but e to the power basically x to the power minus 2. Okay, we can write it as 1 upon e to the power of x and x square. This is the integrating factor. Now the solution is nothing but, solution is y into integrating factor and basically the right hand side, it is nothing but x square, and it is 1 upon e to the power of x into x square. Okay, just let me write it again like this. It is my y is equals to y, or y e to the power of x into x square, and this is the integration of right hand side into e to the power of x to x square dx plus c. Now the x square and x square will get cancelled. This is y e to the power of minus x, x to the power minus 2, and this is nothing but e to the power minus x, the integration of this. So it will be y is equals to e to the power of minus x, and this will be the into to the power of minus 2, and this is minus of e to the power minus x plus c. Now y is nothing but this will get cancelled, or if we'll write here, then e to the power of minus x, e to the power of x and x square plus c, e to the power of x and x square here. Okay, now here I can write y is equals to minus of x square plus c to the power of x and x square. Now what is this? What is the solution? So this I can write it as how can I write this one? So like this one in the form of like this is not y, basically this is u here. Okay, this is not y and this is u. So my u is nothing but y square. If I will write here, this is nothing but y square is equals to c e to the power of x into x square and minus of x square, and then this is the y square, and if I will take x square common, this will be c e to the power of x minus 1. And again, if you are going to write here, this is the thing, and if you are going to solve here, then the solution will be the y square x square e to the power of this is nothing but one thing. Yes, there are the point, we have condition, that is x is equals to 1 and y is equals to 0. It means y at 1 is 0. So by finding this, we'll have the constant. So the constant value is equals to, okay, yeah, just removing this part here, we can find the constant from this. Okay, just let me find it. So this is nothing but the initial condition, which is given in the point, which is given in the form of point. It means that, so my y square is equals to x square c to the power x minus 1. Then here it is what? Y at 1 is 0. So it is 0 is equals to 1. I will put x is equals to 1. Okay, so it will be 1. This one is c. Okay, in minus 1. So this is nothing but 1 is equals to c e to the power of 1, then c is e to the power e. C is 1 by e basically. So y square is equals to x square, then e to the power of x upon e minus 1, then y square is equals to x square, then it will be e to the power of x minus 1 minus 1. Now what can I do? I can just write it as y square upon x square, and it is nothing but e to the power of x minus 1 and minus 1. Now it is y square. So what is this? It is y by x and it is y by x. So these both can't. Now from this I have what? X minus 1. Yes, x minus 1 is there. But if I will write it as y square upon x square plus 1. And if I will take the log, then it will be log and it will be x minus 1. So the first one is the answer, not second. Okay, so this is how we can solve this question. Next one is related to the second order differential equation. Again, we have a differential equation y double dash plus 2y dash minus 5y is equals to 0. And here we have arbitrary constant, that is k1 and k2. Now, what is the solution? Or basically it is a complementary function for this. Just we'll find the auxiliary equation m square plus 2 of m minus of 5 is equals to 0, and it will be minus 2 plus minus root b square, it means 4 minus or plus 20, and it will be yes upon 2, then it is minus 2 plus minus 24 upon 2, then this is minus 2 plus minus, and it will be 24, it means 12 into 2, 6 into 2 into 2, or basically 6 into 4, or basically 8 into 3. Okay, we can write it as 4 into 2 into 3. It means it is 2 root 6 upon 2. So it is nothing but minus 2 upon 2 minus 2 upon 2 root 6 is there. Okay, so here we have minus of 1 plus minus root 6. So this is the like root where my alpha 1 is nothing but minus 1 plus root 6 and alpha 2 is nothing but minus 1 minus root 6. It means these both are different, real and distinct root. So what is the solution for this? Then y is equals to k1 e to the power of minus 1 plus root 6 into e to the power of this and x. This is the alpha 1x. Okay, and second one is k2 e to the power of minus 1 minus root 6 into x. So this one can't. Okay, this one we can't, and again it is the first one is the correct answer for this case. Next. Okay, next question, it is basically the next question is saying that which one of the following is the general solution of first order differential equation. This is the first order differential equation, and it is basically dy by dx is equals to x plus y minus 1 whole square. What is the solution for this differential equation? So what can I do? I can just consider this one, x plus y plus 1, or basically minus 1 is there. Okay, minus 1 is some m. Now it is what? It is 1. If I will differentiate this, it will be dy by dx, and it is nothing but d of m by dx. It means I can replace my dy by dx with dm by dx minus of 1. It means what is this? This is nothing but dm by dx minus of 1 is equals to, I have considered it as m. So it is m square. Now I can separate easily. So it is dm by dx is equals to m square plus 1. Then it is dm 1 plus m square, and it is nothing but d of x. I can just integrate it. It is nothing but tan inverse of m, and this is nothing but x plus of c. Then I can write it as m is equals to x plus of c, or nothing but tan of x plus of c. What is my m? M is nothing but x plus y minus 1 is nothing but tan x plus c. So here it is tan inverse, this is not, it is what? Y. So y is equals to 1 minus x plus tan of x plus c. So it is what? 1 minus x. So D is the correct answer for this question. Next we have a differential equation, the particular solution of this differential equation with the initial value problem given below. Okay, so basically these are the particular solution, and a particular solution in the case of that homogeneous kind of differential equation. So that is nothing but we have a differential equation y double dash minus or plus 12 y dash plus 36 y is equals to 0. So the solution of this differential equation is the complementary function only. We'll just find m square plus 12m plus 36, okay, is equals to 0. This is the quadratic equation. Now what are the root for this differential equation? We are just going to find, it is nothing but the m square plus twice of 6m plus 6 whole square is equals to 0. So it is nothing but m plus 6 whole square is equals to 0. Then m is equals to minus 6 and minus 6. These both are the repeated root here. So what is the complementary function? Whenever we will have repeated root, it will be c1 plus c2 into x e to the power of minus of 6x. Okay, so you, by the options, if all are correct, if all are the same, then you can easily find the root. So no need to do all these things. Okay, so the 6 minus 6 is the root. Now our aim is to calculate the basically the constant from these equations. So we have what? Y of 0 is equals to 3. It means if we will put x is equals to 0, then we'll get 3. So 3 is equals to c1 plus c2 and 0. This will be e to the power of 0 again. Then my c1 is nothing but c1 is 3. Okay, now what is y? Y is the c. Okay, c1 is 0. C1 is 3 here. And I can write it as 3 plus c2 into x e to the power of minus of x. Then I can write it as 3 e to the power minus 6x, and plus it is c2x e to the power of minus 6. And I'm going to differentiate it because it is on differentiation. This condition will be on the derivative part of this. Then the y dash is equals to minus of 18, then e to the power of minus 6x plus this will be the c2, and it will be x Okay, minus of 6 e to the power of minus 6x, okay, and plus it will be e to the power of minus x. Now I'm going to putting x is equals to 0, and it will be minus 36. So minus 36 e to the power of x e to the power of 0, then it will be c2. Okay, this will be 0 because x is equals to 0, only this will be there, only this will be there. Okay, so it is minus 36 minus 18 plus c2, and my c2 is going to be minus 36 plus 18 is equals to c2. So the c2 is equals to minus of 18. So c2 is equals to minus 18, and c1 is basically 3. So my first option is correct here. Okay, next one. Without taking any kind of short trick, you can solve this in the easy manner. There are simple calculations are there. So next question is related to the general solution of the differential equation. It is basically dy by dx here. If I'm going to taking it as, I can separate, basically it is nothing but dy upon 1 plus cos of 2y, and it is nothing but dx, and it will be 1 minus cos of 2x. This is nothing but the variable separation method. So now what can I do? I can just write here, this is nothing but in this case it will be sec of square, or basically cos is, I can just write it as, I can just write cos of 2y is nothing but 2 cos square. Yeah, it will be 2 cos square y minus 1. So I can just simplify it. I can just write it as a sec of square, then it will be cos of square basically, so sec of y dy, it will be 1 by 2 here, then it is again here 1 by 2, and it will be cosec of square y, or sorry, it is x. Okay, and dx plus c. Now here you can write, what is this? This is like 1 by 2, 1 by 2 will get cancelled, and 2 will be there, and it will be again a constant. Now it is nothing but tan of y. Okay, yeah, it will be minus of this will be minus, and it will be minus of cot of x will be there. Okay, cot of x will be there, then it will be c. So tan of y plus cot of x is equals to c. So the C answer is the correct for this question. Next question is related to GATE 2015. Here it is showing that consider the differential equation. Okay, consider the differential equation dx upon dt is equals to 10 minus 0.2 x. Okay, now it is what? That is related to initial value. These are the given condition. It is x of 0 is equals to 1. What can I do here? It is just a variable separation method. I can just write it as it can be variable separation method. I can use just linear kind of differential equation also here. Then it is d of x by dt. Okay, plus 0.2 of x is there. It can't be separated like this, no? Okay, it can separate, but it will be in the integration, it will be complicated. So it will be 10. So I'm going to find the integrating factor. The integrating factor is nothing but e to the power of 0.2x. Okay, this will be the t, not x. Yes, it will be t. So it is the integrating factor. So x into integrating factor 0.2 t, and it will be the integration of right hand side, that is 10. Okay, and integrating factor 0.2 t dt plus c. So it is nothing but x e to the power of 0 plus 0.2 t is equals to e to the power of 0.2 t divided by 0.2. Okay, and plus c. Now I can just simplify here. I can just find the solution is nothing but x e to the power of 0.2 t is equals to 10 upon 0.2. Okay, e to the power of 0.2 t plus c. Oh yeah, wait, it is nothing but 50. Yes, it will be 50 because 100 by 2 is, it will be 50, and e to the power 0.2 t plus of c. Then x is equals to 50, and this will get cancelled, plus c e to the power of minus 0.2 t. Now here you can see, what is this? This is this is not the correct answer. Now from these both will be correct. So from here we can easily see, no need to find the value of C. Of course, C will be the correct answer because it is minus 0.2. So the C will be the correct answer. No need to apply this kind of calculations on this initial value condition. Okay. Next question is related to 2020, 2015 again. This is the 2-mark question. Consider the differential equation. Again, second order differential equation, y double dash plus 3y dash plus 2 is equals to 0. Okay, not y is here. Okay, it is x in the form of x, just for getting confused. So it will be x double dash plus 3x dash plus 2 is equals to 0. We have to condition what is the value of x of 2. Okay, now what is the auxiliary equation? Is this the auxiliary equation? Now what can be the solution? Basically the roots for this kind of differential equation. It is nothing but 2 and 1, of course, plus 2 and plus 1. We can find it as like m plus 2 and m plus 1. If we'll multiply with those like these two factor, we'll get, so it is m is equals to minus 2 and minus 1. These are the real and distinct root, so that y is equals to c1 e to the power of minus 2t plus c2 e to the power of minus t. Now I have condition that is x of 0 is equals to 20. It may, oh, sorry, again it is not x, it is not x, it is y. Okay, my x is equals to 20 here, so it will be c1, it will be 0, and c1 plus c2. Okay, and next one is that x1 is equals to 10 by e. It means it will be 10 by e here, and it will be 10 by e here, and 1. So it is c1 e to the power of minus 2 plus c2 e to the power of minus 1 here. Okay, so from here I can find the value of c1 and c2. This is the like calculation you can do after getting you will find the c1 and c2 from this equation. You will find c1 and c2, and after that you are going to put in this equation. So c is equals to, x is equals to some constant c1 e to the power of minus 2t and some constant e to the power of minus t, and after that you will just put here 2 and 2. So this is all about the calculation part. I'm writing the answer. So the correct answer is 0.85. Do the calculation and find the solution. Okay. Next, this is the again related to 2015. Sorry, the solution of the differential equation. So what is the solution? Same kind of the differential, same kind of thing is here. It is the second order differential equation, y double dash plus 2y dash plus 1 is equal plus y is equals to 0. It means the auxiliary equation is m square plus 2m plus 1 is equals to 0. And it is what? It is nothing but m plus 1 whole square is equals to 0. Then it means it have a repeated root. It means minus 1 and minus 1 are the repeated. Now see, if we have a repeated root, then it is what? E to the power of t. It is not, it can't be the answer. It is minus 1. Yeah, it may be, but it can't. Now from these both, how can we find? So for that, we will have to write the solution. So y is equals to c1 plus c2. If it is a repeated root, then we'll write in the form of this. So this is the general form. Now we have condition. So you can find either c1 or c2, or if you will get any kind of like any arbitrary constant, that you can easily find out the solution. So I'm just applying my y0 is equals to 1. I'm going to put t is equals to 0. It means 1 is equals to c1 plus c2 0, and it will be e to the power of 0. It means my c1 is equals to 1. So if c1 is equals to 1, then of course this will be the solution. Okay, next. So the next question is related to 2014. It is if a and b are my constant, then the most general solution of the differential equation is what? So first of all, this is the same differential equation that I have written in the previous section. That is basically the x double dash plus 2x dash plus x is equals to 0. And the auxiliary equation is m square plus 2m plus 1 is equals to 0. Then it is nothing but m plus 1 whole square is equals to 0. So the roots are minus 1 and minus 1. If the roots are minus 1 and minus 1, then of course it will be in the form of c1, or if arbitrary constants are my a and b, then it will be a plus b of t e to the power of minus t. Then I can write a e to the power of minus t plus b t into e to the power of minus c t. So most general. This is the solution. See, Whenever you will have this kind of differential equation, then this is again individual solution, this is again individual solution. It is saying that it is a most general solution, not about the same. If it is talking about the solution, then of course this will be correct, but it is not talking about the solution, it is talking about the most general solution. So this can't be and this can't be, so this is the solution. So the B is the correct answer for this question. Okay, next one is that we have a differential equation or the characteristic equation of differential equation. So characteristic equation of differential equation has the real root. It is what is saying that has the two real roots. Okay, then the value of alpha r. So it has two real root. It means what is the for what value of alpha it will be the solution. Okay, now in this case, what is this? This is y double dash plus 2 of alpha y dash plus y is equals to 0. So see, two real roots saying that if it is a j, it means it is an imaginary part. We can't consider it as like this. Okay. Now, for what value of alpha it is like this? So it is m square plus 2 alpha m plus 1 is equals to 0. If it is if it have a real like two real roots are there, na? So it will be minus of 2 alpha then plus minus b square. Okay, then it will be 4 of alpha square minus 4 upon 2. Okay, now if it is if it have two real root, then we can find the solution, or basically the characteristic equation of this has two real root, the value of alpha. If we'll put here, see, one thing is that we have this case, then we can find the root from here, that is minus of 2 alpha plus minus or divided by 2 here, and here from we can take alpha square minus 1 upon 2, then it will be minus of alpha plus minus, it will be root of alpha square minus 1. For real root, see, my alpha is a real number from here. For yes, one thing is that this option we can't discard for now, but if it has a real root, then inside the radical part it must be greater than 0. It means my alpha square minus 1 must be greater than 0, then alpha square must be greater than 1, then alpha is basically alpha must be greater than plus minus 1. See, alpha must be greater than plus minus 1, not 0 comma 0, not 1 by 2, and the most correct answer for this will be the plus minus 1. Okay, so this is the concept of this differential this question. Now next question is related to with the initial value. This is what y0 is equals to y0 and y dash of 0 is equals to 1. These are the initial condition given here. Then what is the value of solution at x is equals to 1? So we have differential equation y double dash minus 4 y dash plus 4 is equals to 0, and it is the auxiliary equation is m square minus 4m plus 4 is equals to 0. What is this? This is nothing but m minus 2 whole square is equals to 0. So it has two repetitive root. So the solution is nothing but c1 e to the power of c1 plus c2 plus c2x e to the power of plus of 2x. Okay, now if I will use these conditions, then y of 0 is equals to 1. It means y value of y is 1, then x is 0. Okay, so this is c1, so my c1 is equals to 1 here. If my c1 is equals to 1, then I can write c2x e to the power of 2x. Now what is the y dash here? So y dash is nothing but, first of all, just let me write it as a simplest form. So e to the power 2x plus c2x e to the power of 2x here. Then the derivative of this y is nothing but here it is 2 e to the power of 2x plus, and it is basically c2, and I'm going to use the derivative u into v. Then if I will first differentiate of x, then it will be 2 of x, and again it will be x 2 e to the power of 2x. Now I can put x is equals to 0. If I will put x is equals to 0, then this term will get cancelled, or will be 0 basically. Then it is y, and it will be 2 plus c2, and it will be 1. So my c2 is nothing but minus 1. So my general solution will be c1 is 1, so it is 1 minus of x e to the power of 2x. Now what is x1? So it is nothing but y is equals to 1 minus 1 e to the power of 2x, or if I will put 1 here, then of course it will be in this case here we have minus 2. Okay, just let me check it again. It is it will be 0, and if we'll put 0 in this case, then it will be 1 minus 1, then c2 is minus 1. Okay, so if we will put x is equals to 1, then of course it will be 0 here in this case. 1 minus 1 will be 0, m square 2. Okay, c1 plus c2, if I'll put will be 0, then c1 is 1. Yeah, it will be 0. So this is the correct answer for this question. Next will be the question which is related. Okay, one thing is that, just let me check it here. If I will differentiate, it will be 2 here, it will be 2 here, this will get cancelled, this will be minus of 1, then yes, it's the correct answer. Okay, next one. So the next question is again 2014. So which one of the following is a non-linear, non-homogeneous differential equation? Okay, linear, non-homogeneous. Linear and non-homogeneous. There are two concepts. One is that linear. So linear kind of means degree of that differential equation must be 1. There is no y square term is there. It means whenever we will have dy by dx, this is independent variable and this is dependent variable. No higher power of dependent variable, and no multiplication of this kind of, and no non-linear function of dependent variable. If all these three, if all like these three conditions are there, then it will be non-linear case. Otherwise it will be linear. Now non-homogeneous means that if you have a differential equation of like this, f of x, if my f of x is equals to 0 here, then it will be homogeneous case. Or if my f of x is not equals to 0, then it is non-homogeneous part. Okay, so now in this case, first of all, this is what f of x is equals to 0, then this is homogeneous, and this is homogeneous. Okay, this may be non-homogeneous, this may be non-homogeneous, but see, this is what? This is the non-linear function of dependent variable. Then it is what? Non-linear differential equation. So this can't be the correct answer. The correct answer is the first one. Here it is e to the power of x, but it is a non-linear function of independent variable, not the dependent variable. Okay, next one. So the next question is related to 2012, and it is a 1 mark question, and it is that we have an initial value problem. Of course, we can write it as dx by dt plus x upon t is equals to 1. Okay. Now, what is the integrating factor? We will just find integrating factor 1 by t dt, and it is nothing but log of t, and it is t. So this will be the x into integrating factor, and the integration of right hand side into integrating factor dt plus c. So x of t is equals to, this will be the t square by 2 plus c. Now x is equals to t by 2 plus c by t. Now we have condition is that x of 1 is equals to 0.5. It means if we will put t is equals to 1, we'll get 0.5 here. So t is my 1, so 1 by 2 plus c. So my c is equals to 0.5 minus 0.5. It means my c is equals to 0 here. Okay, just let me check. I'm making any mistake here. It will be t square by 2. Yes. T is equals to 1. No? Okay, t is equals to 1. It will be 0.5. It will be 0.5. Then I think there is a mistake here. It is minus of 0.5. Okay. If it is minus 0.5, then it will be 1. If my c is equals to 1, then what is the solution in that case? So my solution will be t by 2 minus 1 by t. So here, if I have t square by 2, just wait, it is okay. No. Yeah. Not it. Yes. No need to take care of this. This is positive. Then c is equals to 0. If c is equals to 0, then what is the solution? Then x is equals to x of t. Then it will be t. Okay, it will be t here. Then x is equals to t by 2. If it is x is equals to t by 2, so this may be the answer for this. These both are equal. Na? If I will write it as t square by 2 by t, then it is get. These both are the correct answer for this case. I don't know why these both are given in the same. These both are the correct answer. Okay, next one. So the next question is related to the solution of differential equation. It is a simple first order linear differential equation. Whenever you will have these kind of differential equation, remember the solution for this kind of differential equation is like that, dy by dx, and if it is a differential equation of the form of some ay, then the solution is nothing but y0 e to the power of a, ay. So it is what the solution is nothing but c e to the power of ky. So it is nothing but c e to the power of ky. So this one be the answer for this? I don't think so. No, it's not y, it will be x. The dependent variable will be there, of course, because if you are going to solve this by separate variable, separate method, then it will be k d of x, then it will be log of y, and it will be k x plus c. Then y is equals to, if I'm going to taking as log of c, then it will be c to the power of kx. So C answer is the correct answer for this. So the next one is the differential equation, in which it is saying that the function n of x satisfying the differential equation, this is nothing but n double dash minus 1 by L square n is equals to 0, where L is the constant. The boundary condition is here, it is what, n of 0 is equals to k and n of alpha is equals to 0. Whenever you will have this kind of boundary condition, then how can you solve this? This is simple. You are going to taking what, m square minus 1 by L square is equals to 0. Then it is what, m square. Okay, so it is nothing but m square is equals to 1 by L square, then m is nothing but plus minus 1 upon L. Then this is what, it is nothing but my c1 e to the power of 1 by L into x plus c2. So the solution n will be this, okay, and it will be e to the power minus 1 by L into x. Now you are going to use these two conditions. So first one is, if my x is equals to 0, then n is k. So it is k, x is 0, then it is c1 plus c2. Another one is x is equals to alpha, then cn will be 0. So it will be c1 e to the power alpha upon L plus c2 e to the power minus alpha upon L. So what can I do? I can just find c1 and c2. I can just replace from here. The c1 is nothing but, k minus c2. If I will replace it here, then it will be 0 is equals to, so k minus c2 e to the power of alpha by 2, sorry, alpha by L, not 2, plus c2 e to the power of minus alpha by L. Then it will be k e to the power alpha by L minus c2 e to the power alpha by L plus c2 e to the power minus alpha by L. Okay, so from here we can find one thing is that we can take from here, we can just write k e to the power minus alpha by L. Then if we are going to taking c2 common, okay, plus c2, then minus e to the power alpha by L is there, and plus e to the power minus alpha by 2 will be, minus alpha by L will be there. So in that case, we are going to find c2. So from here we can find c2. Yes. Okay, we'll just find c1 and c2 from here. No? So from here c2 will be k minus of k e to the power minus alpha by this upon minus e to the power alpha by L plus e to the power minus alpha by L. So this will be the c2 here. If I will replace with this, and I'll get the solution. So for this, the solution will be the like not root alpha will be there. So from this will be the k square will not be there. So the first answer is the correct for this case. Okay, you can find with the idea you can solve this question. Okay, next one. So for the order of differential equation, what is the order of differential equation? Order means that highest order derivative, or basically how many times highestly it has the derivative has been like differentiate. So of course it is a second order differential equation, because the higher order derivatives are here uh, d2. Okay, so d2y by d2y by dt square is there, so it's the second order differential equation. So the next question is related to match each differential equation of group 1 to the family of its solution and curve in group 2. So what kind of differential equation is representing the what kind of family of solution? So first of all, what I have, this dy by dx is nothing but y upon x. So I can separate it. This will be dy over y, okay, and it will be dx over x. So if I'm going to integrate, this is nothing but log of y is equals to log of x plus log of c. It will be there. So it is nothing but I'm going to taking as log of y, and this will be log of c into x. Then y is equals to cx. What is this? This is nothing but straight line. Okay, this is nothing but a straight line. So my p will be straight line, means p will goes to 2. So if p is going to 2, then this one will not be correct. This will not be correct. Now see another one, dy over dx is equals to minus of y upon x. Now if you are going to taking it as dy over minus of y, or yes, minus of y, and this will be the dx over x, and again it will be minus log of y, and it will be log of x into c. Then this will be 1 upon y. Okay, this will be 1 upon y, and this will be 1 upon y is equals to xc. So what is this? This is nothing but y is equals to 1 upon x by c. So these kind of curve is representing the hyperbolic shape, like this kind of shape. So this is not a straight line, this is not hyperbola. So yeah, this is not the circle, this will the hyperbola. So y 1 by x. Okay, so this is basically hyperbola. So q is going to 3. So if q is going to 3, yeah, again like this will not be the correct option, so a is the correct option for this. Okay, next. So the next question is related to which of the following is the solution of differential equation. So we have a differential equation, dx over dt is equals to 3, oh yeah, plus 3x is equals to 0. Then we can take it as dx over x is equals to minus 3 dt, variable separation method. Then log of x is equals to minus 3t and plus log of c. Why I'm taking this constant in terms of log? Because of that it is a x. Then I can just remove log by this. So it will be log of x by c and e to the power 3t. So it will be x by c e to the power of e to the power of minus 3t. Then x is equals to c e to the power minus 3t. Whenever you will have this kind of differential equation, dy by dt is equals to some a of y with some initial condition, or with some initial condition x0 is equals to y0, then the solution will always be y is equals to y0 e to the power of ax. So this is the what? E to the power of this minus of 3t. Now we have initial condition is that x of 0 is equals to 2, then it will be 2 and it is c. So my c is equals to 2, so it will be 2 e to the power of minus 3t. Okay, so B answer is the correct answer. Next one. So the next solution is again related to the differential equation, in which the solution of differential equation is y double dash. Okay, it is basically y double dash minus of 5y dash plus 6 is equals to 0. In this we have to find the solution only. So the characteristic roots, what are the characteristic roots? You can just take, what is this, minus 5 and this. So obviously this is 3 minus 3 and minus 2. So these are the root. So from here it is 2 and minus 3. It will not be it will not be again, it is not, yes, it is the correct answer, because it is a minus 2 and minus 3. No need to like bother about C1 and C2. What are the C1 and C2? Just get. Okay, one thing is that if it is -3 and -2, if I'm going to take -3 -2, one thing, wait, just 3 or 2 is there. M square minus 5m plus 6 is equals to 0. Then it is what? 5 plus minus 25 minus 25 plus 24. Okay. Or in this case, if I'm going to write like this, plus 2, then it will be positive, whole positive will be there. I think there is a problem with this. This will be positive in this case. Otherwise, yeah, for this, it is the correct answer. Okay, I'm multiplying this with 3. Okay, this is the correct answer for this question. Yes. So the next question is related to, again, second order differential equation. Okay, yeah, it is asking about the order and degree. So the first one, the order of this differential equation is 2. Okay, because the higher order derivative occurring is 2. So the order is 2. Order is 1 is not correct. Order is 3 is not correct. Order is 1 and degree is 1. Of course, the power for this is 1. Okay, next one. So this is the differential equation. It is what? Y is equals to e to the power of minus 2x. And this is the solution of the differential equation y11 minus y. It is not double dash. It is 11 and y power 1 minus 2y is equals to 0. Okay, think. Is it a solution or differential equation or not? It means if it is a solution, then it will satisfy. Of course, it will satisfy. Then here, the thing is that it will not satisfy. If you are going to differentiate this thing, then it is nothing but 2 power. Like what is the y differentiating? We are differentiating 11 times. Then it is minus 2 power 11 e to the power minus 2x, and it is minus or plus 2 e to the power of e to the power of minus 2x and plus or minus 2 e to the power of minus 2x is equals to 0. Now see, what is it, a 0 or not? Is it really satisfying the differential equation or not? So I'm going to taking 2 common. If it is where I will take 2 common, then it is nothing but, or not 2, basically it is minus of 2 e to the power minus 2 of x. Then it will be what? It will be, or plus 2, then it will be minus 2 to the power one thing. Then it will be basically, if I will take minus 2 common, then it will be minus 2 power 10 will be there. Minus 1 will be there. Okay, plus 1 will be there, is equals to 0. Okay, this can't be 0. So minus 2 e to the power minus 2x can't be equals to 0. Then this minus 2 10 to the power 11, is it equals to 0? Of course not. It is not satisfying. Okay, yeah, it is not the solution of this differential equation. So thanks for watching my video. Keep watching MS Maths. These are the questions related to the GATE CSE ECE branch. Now next videos we'll discuss all the different branches. Thanks for watching my video. Keep watching MS Maths. Thank you. Bye bye.